Dear colleagues, participants of the Third International Workshop on Computer Modeling and Intelligent Systems, I would like to present you the study results from the VNTU and LPNU authors team on the topic of linguistic analysis method of Ukrainian commercial textual content for data mining. Authors are Oleg Bisikalo, Dean of the Faculty for Computer Systems and Automation at Vinnytsia National Technical University, and Vysotska, Assistant Professor at the Department of Information Systems and Networks at Lviv Polytechnic National University. I will be talking about our suggested approach to automatic detection of significant keywords and rubrication of Ukrainian content in Internet systems, based on the method of linguistic analysis of textual information. In this work, we define the basic requirements and procedures of syntactic, semantic, referential, and structural analysis of Ukrainian language commercial content. The method is aimed at automatic detection of significant keywords of Ukrainian language content on the basis of the proposed formalization of grammatical, morphological, syntactic, semantic, referential, and structural components of the analysis. This study had solved the task of comparative analysis and choice of an optimal statistical method for determination of stable word combinations, while identifying keywords to process English language and Ukrainian language web resources. The effectiveness of the method directly depends on the quality of linguistic analysis of Ukrainian and English texts, respectively, based on the technology of web mining, data mining, and NLP. A decomposition of methods of linguistic analysis was performed to determine the impact on the quality of the formed stable word combinations as keywords. The features of this method are an adaptation of the morphological and syntactic analysis of lexical units to the peculiarities of Ukrainian language words texts. To determine stable word combinations effectively, it is essential to exclude functional words, pronouns, numerals, and verbs because they are not related to the subject and content of the published work. A set of stable word combinations acting as keywords is determined by qualitative morphological and syntactic analysis of relevant texts. The set of the identified stable word combinations is used further to compare and determine the degree of the text relevance to specific topic or user request. The internal dynamics of the formation of these sets, depending on the statistical method applied to the text, was investigated in the study. As a functional semantic structural unity, the text conforms to the rules of construction, reveals the regularities of content, and formal connection of constituent units. Cohesiveness is manifested through external structural indicators and formal dependence of the text components, and integrity through thematic, conceptual, and modal dependence. Integrity leads to a meaningful and communicative organization of text, and coherence to a form, a structural organization. Therefore, it is proposed to analyze the multi-level content structure in the following order: linear sequence of characters, linear sequence of morphological structures, linear sequence of sentences, and a network of interconnected unities. A minimum content unit of written text is called a grapheme. The objective of this level of recognition is to build a formalized representation of the grapheme structure of the text and to develop a formal apparatus for separating and classifying text units on multiple lines and graphs. Generalized recognition algorithm works with following restrictions on the input text. Formatted width, does not contain hyphenation, does not contain objects such as tables, figures, formulas, or graphic symbols, and submitted in known languages such as English, Ukrainian, and German, rather than ancient Egyptian, Mongolian, or Elven. The ultimate goal of recognizing the graphemic level of text representation is to build a grapheme structure of the text. This includes separating such semantically independent units of texts as fragments, sentences, syntagm, tokens, and defining the types of enumerated units of the text, and defining the relationship between them in a specific input text based on the plurality of the lines and graphemes of the input. The process of recognition at the grapheme level of the text representation involves two stages, as shown in Figure 2. Stage 2 is to perform morphological analysis of textual content, is to find the basis of verbs, for example by cutting out suffixes, prefixes, etc., leaving only the basis of the word. This process is called stemming. There are known algorithms for this process. They also cut out the keywords with a simple word selection function, and then each word is recognized by the base and written into the table. Stage 3 is syntax analysis of textual content. Syntax is known to be a set of rules that makes it possible to construct formulas and recognize the correct formulas in a sequence of characters. It is important for the symbolic computation systems that all but one of the expression logic operators are binary. This will be based on a parser. Step 4 is the semantic analysis of textual content. Latent semantic analysis is a method of processing information in a natural language that allows you to analyze the relationship between a collection of documents, messages, articles, in example textual content, and terms, keywords, that occur in them. This is done by a comparison of some factors or topics to all documents and terms. Initially, words correlate with semantic vocabulary classes, and then the morphosemantic alternatives needed for this sentence are selected. What follows is the linking of two words into a single structure and the formation of an ordered set of superposition entities of basic lexical functions and semantic classes. The accuracy of the result is determined by the completeness correctness of the dictionary. Step 5 is the additional analysis and the formation of interface unities. A contextual analysis of textual content is carried out. With it, the resolution of local references is performed, and the expression of the expression is the kernel of the unity. The following is a thematic analysis. Separation of statements based on the theme and rhyme allocates thematic structures which are used, for example, for a formation of a digest. Define regular repeatability, synonymization, and renomination of keywords. The identity of the reference, that is, the relation of the words to the object of the reflection. Presence or implication based on situational connections. And step 6 is a structural analysis of textual content. The prerequisites for this are a high degree of coincidence in terms of unity, a discursive unit, a sentence in a semantic language, utterance, and an elementary discursive unit. A basic set of rhetorical relationships between content unities is identified, and a non-linear unity network is constructed. The openness of a link set involves its extension and adaptation to analyze the structure of the text. There are several ways to use semantic analysis to define keywords as a phrase, that is, to define terms in nouns, noun phrases, or noun adjective among a plurality of text content words. 100 scientific publications within the bulletin of Lviv Polytechnic National University of the series Information Systems and Networks from issues 783 and 805 were selected as the linguistic base for the experimental study of the proposed method. The analysis of the statistics of the keyword detection system's function was carried out in two stages. In particular, all articles were analyzed by checking common block words and thematic vocabulary, and all articles were analyzed by checking refined blocked words and refined thematic vocabulary, with more startup, a set of unknown words, missing both in the thematic dictionary and in many blocked ones, is formed. In addition, at each stage the review was performed in two steps for each article: analysis of the entire article and the analysis of the article without the introduction, which includes title, authors, editors, annotations in two languages, author keywords in two languages, author's place of work, etc. And no literature list to determine errors in the accuracy of multiple keyword formation, which is shown in figure 3. Keyword accuracy is enhanced during the dictionary moderation process. The difference between the number of keywords identified by the author and the system, defined in the step 1 of the stage 1, is 44%. And the 44% is the percentage difference between the number of keywords determined by the author and by the system. The accuracy is improved in step 2 of the stage 1, and it now is at 33.71%. And it is further significantly improved in the first and second steps of the stage 2, which is now at 24.3 and 14.97% respectively. In the table 1, the results of the analysis of the statistics of the set of the potential keywords for each article is compared to the set defined by the authors of the articles, where A is for the author's keywords, B is for the system-defined keywords in stage 1, step 1, C is for the keywords defined by the systems in stage 1, step 2, D is for the stage 2, step 1, and E for the stage 2, step 2. The author of scientific article usually chooses at his discretion and the number of keywords in the range of 2 to 8 words, most often 3 to 5 keywords. The system also defines a different number of words depending on the writing style of the particular author. There are articles in which the system does not find any keywords, for example. For group B, most often the system determined the number of keywords 3, 7, and 5, or more than 10, although the distribution of found keywords range from 1 to 18 words. For group B, the system most commonly identified keywords as 5, 7, and 3, although the distribution of keywords found ranged from 1 to 18. But the number of keywords found increased and the highest reliability was achieved. For group C, the system most often determined the number of keywords 7, 6, 5, 10, and 8 through the distribution of found keywords ranged from 2 to 14 words, significantly narrowing the range compared to step 1, stage 1. For group D, the number of keywords was found to be 8, 5, 7, and 10, and the distribution of keywords now ranged from 3 to 16 words. The study has produced results of the experimental testing of the proposed content monitoring method for determining stable keyword combinations to identify keywords in the processing of English language and Ukrainian language web resources of the technical content based on the web mining technology. It has been determined that the authors of published works often identify the keywords that are far from being considered. It has also been proven that the quality of the result is influenced by the quality of the linguistic analysis of text and subsequent filtering. The obtained results have been verified. Further experimental research requires approbation of the proposed method for determining keywords for other categories of texts: scientific, humanitarian, belletristic, journalistic, etc.